Hello, Intro to Chem students. We are jumping into chapter 10, and I have just a little kind of a wacky little video that that kind of comes with the curriculum. So I want to play that for you first.
The mole is an especially useful tool for chemists because it allows them to express the number of representative particles of a substance in grams. For example, a mole of carbon atoms has a mass of 12 grams. Huh? Oh, my brain hurts.
Ciao, signorina. I understand that you're having a little trouble understanding the mole.
Who are you? Why are you in my room? And why are you dressed so funny?
Actually, you're in my room. You've traveled back 200 years. This is my office in this high school in Turin, Italy.
I must not be drinking enough water after I run. Maybe I'm dehydrated, delirious.
You're not delirious. You're just dreaming. It happens all the time. So, tell me, what kind of problems are you having understanding the mole?
Okay, just go with the flow here. Eventually I'll wake up and everything will be back to normal, right? How can you help me understand the mole?
I am none other than Count Lorenzo Romano Amadeo Carlo Avogadro. You know, the lawyer turned scientist who determined that equal volumes of gases contain equal numbers of particles. Actually, it's a good thing that the Frenchman Joseph Louis Gay-Lussac had already published his law combining volumes. That's what helped me determine my gas law. That's named after me, you know. Avogadro's hypothesis.
Wait a minute. I thought you had different facial hair. And I thought Avogadro had something to do with some number. Wait, that's it. Yeah, that's right. Some really big number. I remember 6.02 times 10 to the 23rd. Avogadro's number.
Yes, well, first of all, I just went cycling in Spain. This is all the rage. And actually, some other guy is going to figure that number out 50 years from now. But he's going to name it in honor of me, too.
That's pretty cool, but so what?
Well, that number is the amount of particles in 1 mole of something, usually atoms or molecules. Oh, like the dozen eggs you bought. How many eggs are in that dozen?
12?
So, a dozen eggs contains 12 eggs. A mole of an element like carbon contains 6.02 times 10 to the 23rd atoms of carbon. The mole of a compound like carbon monoxide contains 6.02 times 10 to the 23rd molecules of carbon monoxide.
So what?
So what? So, now that you know that every mole contains the same number of particles, you can calculate the mass of a mole in any element or any compound. Again, take carbon, for example. A mole of carbon has a mass of 12 grams. How do you get that mass? By converting the atomic mass of carbon, 12 AMU, to grams. The mass of a mole of an element or compound is called its molar mass. For compounds, you can calculate molar mass from the atomic masses of the elements in the compound. For example, what's the atomic mass of oxygen? 16 AMU. So, what's the molar mass of carbon monoxide?
28? And so that's 1 mole of carbon monoxide, right?
Esattamente, signorina.
Hey, I think I get it. So if you know about the mole, you can predict what will happen in a reaction. And that means you will know how much carbon monoxide you get if you combine, say, 2 moles of carbon with 1 mole of oxygen molecules. 56 grams. Cha-ching!
So what?
So that would be totally important. Like if you had to make a certain amount of something, you could calculate the total amount of raw materials you needed.
Exactamente.
Oh, okay. I gotta wake up now so I can finish my homework. Wake up, wake up, wake up.
And don't forget, non fermati mai esplorare il vostro mondo.
All right, so that dorky little video was an introduction to what moles are in chemistry. So moles in chemistry are a way, because atoms and molecules are incredibly tiny, even a very small sample can have a huge quantity of them. So we usually we don't talk about, oh, I have 7 million atoms of this, for example. Instead, this gives us a way to talk about them in quantity, but not in eaches, if you will. So as we move through this chapter, and I'm actually going to break this chapter into 2 and maybe 3 separate kind of components, if you will. So we'll have smaller, more spaced out assessments, just because this chapter is huge. I mean, it's huge, and so I don't want you to be overwhelmed. So we will learn kind of the first part, and then we'll have a short assessment on that, a quiz, if you will, and then we'll go to the second part and have a quiz and kind of break it down, because I know that it's just a lot of information. This tends to be the most difficult chapter, I think, of the year. So we're going to break it down. So it's going to be pretty simple. So moles allows us to convert among, volumes and kind of eaches and mass and grams, and explains by the end of this first part, you're going to be able to, if you had a sample of pure substance, you're going to be able to tell me how many atoms are in that. So you're going to become atom counters and molecule counters, which is pretty cool. And then we're going to talk about molar mass just really briefly. So remember on the periodic table, what information we actually have. And I don't love this one, I'm not going to lie, because it doesn't have both numbers. So this periodic table has just the atomic number, but if I click on, this is interactive, see how this lights up here when I go to an element. So it does tell me that the atomic number of magnesium is 12. The atomic mass is 24.305, and that's actually the mass. We don't use, pounds or ounces or even grams when we talk about the mass of atoms because they're so tiny. We use something called atomic mass units, if you remember from earlier this year or 9th grade physical science. So this is in atomic mass units, and that actually, we'll talk about that a little bit more later. But when we talk about the molar mass, what we are saying is, if I have the atomic mass, so this 24.305, only I have that many grams of this substance, that is actually 1 mole of this substance. And then we also know that 1 mole of a substance is this really cool number, which we call Avogadro's number. 1 mole of any particles is 6.02 times 10 to the 23rd. And the really cool thing, again, about this number is, if I look at the periodic table, so remember I said, okay, magnesium, if I look at the periodic table here, so magnesium has an atomic mass of 24.305 atomic mass units. If I have that many grams of magnesium, it is 1 mole. It works for every element on the periodic table. Calcium has an atomic mass of 40.08 atomic mass units. If I have 40.08 grams, I have 1 mole, which is 6.02 times 10 to the 23rd particles. Carbon atomic mass of 12.01 atomic mass units. if I have 12.01 grams, then I have 1 mole of carbon. So that's why it's called the molar mass. I can have any element on the periodic table, and if I have this many grams, here's iron. If I have this many grams of iron, 55.84, that means I have 1 mole of iron. And 1 mole is this magic number called Avogadro's number, 6.02 times 10 to the 23rd atoms of carbon, right? Or iron, or whichever one I'm using. So this was a really incredible number when we figured this out, when scientists figured this out. This was a game changer and life-changing, because now anybody could find the mass of a pure substance and know how many particles that was. And that became important, especially when we started synthesizing or making compounds that were composed of more than one type of atom. So let's start with just finding some molar masses of some simple substances. Okay, so let's apply what we just learned. So I'm going to find the molar masses of these substances. Hopefully everyone remembers what AU is. I know you studied this at the end of last semester. I'm just going to put little equal signs here, and then we're going to go through how to do this. So I got to find AU on the periodic table. I'm going to go to my handy dandy periodic table. AU is gold. You always remember that. AU, give me my gold. So finding gold on the periodic table, element number 79. So it has 79 protons, 79 electrons, and look at the molar mass. Oh, I have to stay on here. The molar, or the atomic mass, is 196.97. If it's really close like this, we can round this to 197. So I'm going to go back. So for gold, it is 197. So what that really means is it's 197 grams per mole. Now let's look at sodium chloride. This is going to be a little different because it's not just one element, it's 2. So I have to look up sodium, and I have to look up chlorine. All right, so sodium, I'm going to get back to my arrow so I can make this interactive. So sodium, 22.99, I can round that to 23. And then, so remember that number, 23, and chlorine is 35.45. So I can round this to 35.5. I'm going to go back to, so 23 plus 35.5. We'll do the math really quickly. So you'll notice it's 58.5 grams per mole. I can use that as a conversion factor, and we will do that. So 58.5 grams in 1 mole. That's what molar mass means. And then let's look up aluminum and oxygen. All right, so aluminum, 26.98, so 27. And oxygen is 15.9994, which is, we'll round that to 16. So 16 and 27. Okay, so just to save time, I wrote that, so I have 2 aluminum. Remember we said aluminum is 27, but there's 2 of them. That's what this subscript means. So 2 times 27 is 54. 3 oxygen, so 3 times this 16, which gives us 48. So for aluminum oxide, the molar mass is 102 grams per mole. So those are the molar mass. So, and again, remember, if I have 1 mole of these, I have 6.02 times 10 to the 23rd atoms or molecules of that. And that is molar mass.